Students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the concept of the Controlled Access Protocol. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the third type of protocol named as the Channelization Protocol. We have seen the random access protocols, the controlled access protocols, and the last one is the channelization protocols. The channelization is a multi-access method in which the available bandwidth of a link is shared in time, frequency, or through code between different stations. Basically, there are three major techniques which are used to share the available bandwidth in a wireless communication system, that are frequency division multiple access, that means FDMA, time division multiple access TDMA, and code division multiple access CDMA. That means in channelization protocols there are mainly three types: FDMA, TDMA, CDMA. Let's see details about each one by one. The first one is the frequency division multiple access, or the FDMA. In frequency division multiple access FDMA, the available bandwidth is divided into frequency bands. Okay. Each station is allocated to a band to send its data. In other words, each band is reserved for a specific station and it belongs to the station all the time. The station also uses a band pass filter to confine the transmitter frequencies. To prevent station interferences, the allocated bands are separated from one another by small guard bands. For example, if there are 4 stations, then the available channel bandwidth, this is the channel bandwidth, is divided into the 4 bands. Okay, each band is used for each station, that means this band is used for the station 1, this is used for station 2, this is used for station 3, and this is used for the station 4. Okay, that means during this band only station 1 can send its data, during this band only station 4 can send its data. I hope you all understand the frequency division multiple access system. Okay. The available system bandwidth. Here is the diagram for the frequency division multiple access is shown, in which we can see that the available system bandwidth W is divided into n non-overlapping bands, each of width WU. That means this is the total available system bandwidth W. This W, or this bandwidth, is divided into the total number of channels available. Okay, for example, if there are 6 channels available, then W is divided into its 6 part. Okay, I hope you all understand the concept here. A guard band is provided between bands W to reduce the interference from the adjacent channel. This area or this space is referred as the guard bands, and these guard bands are used to reduce the interference between the two channels. The interference means if this is channel first and if this channel second, then this area is known as interference. To reduce this interference, the channel first and channel second are separated by a band named as the guard band. The bands W are assigned on demand to users who request service. During the period of service, no other user can share the same frequency band. Okay. This is the detailed diagram of the frequency division multiple access is shown, in which here we can see that there are total 4 stations: station 1, station 2, station 3, and station 4, and the entire bandwidth is divided into the 4 bands 1, 2, 3, and 4. Here station 1 has the first frequency band, Station 2 has the second frequency band, station 3 has the third frequency band, and station 4 has the fourth frequency band. During the first frequency band, only station 1 can send its data. Or during the fourth frequency band, during this band, only station 4 can use it. Station 2, station 3, station 1 cannot use this band because this all station has its separate bands. This is the concept of the frequency division multiple access. Now let's see the features of FDMA. In FDMA, every user shares the frequency channel simultaneously. However, every user transmits at a single frequency. FDMA is compatible with both digital and analog signal. This is the main advantage of the FDMA, that it can be used with digital and analog signals or data. FDMA demands highly efficient filters in the radio hardware, contrary to CDMA and TDMA. FDMA is devoid of time issues that exist in TDMA. As a result of frequency filtering, FDMA is not prone to the near far problems that exist in CDMA. All users transmits and receives at the different frequencies because every user receives an individual frequency slot. The complexity of FDMA is lower, the bandwidth of each channel is narrow. These are the features of FDMA. Let's see some disadvantages of FDMA, such as the FDMA does not differ significantly from analog systems. Improving the capacity depends on the signal to interference reduction or signal to noise ratio. The maximum flow rate per channel is fixed and small. The guard bands leads to the waste of capacity. Hardware implies narrow band filters which cannot be realized in VLSI and therefore increases the cost. These are the disadvantages of the FDMA system. Now let's see the next one, time division multiple access or TDMA. TDMA is a digital technique that divides the signal single channel or band into the time slot. Each time slot is used to transmit one byte or another digital segment of each signal in sequential serial data format, that is, in time division multiple access or in TDMA, the station shares the bandwidth of the channel in time. Okay, in FDMA, the channel is divided into the frequency bands, while in TDMA, the channel is divided into the time slots. Okay, I hope you all get the basic difference between FDMA and TDMA. Each station is allocated a time slot during which it can send data. Each station transmits its data in its assigned time slot only. This technique works well with slow voice data signals, but it's also useful for compressed video and other high speed data. This is the basic data transmission frame is shown, in which we can see that there are total m number of stations and hence there are total m number of time slots are present here, in which the each station has its own time slot. Okay, the slots grouped into the frames, that means the all the slots are grouped into the frame. This is the first frame, this is the second frame. Only one user is allowed to transmit or receive in each slot. Each user occupies a cyclically repeating time slot. Thus channel may be through as per particular time slot that recurs every frame. Okay, in TDMA system, the transmission for any user is discontinuous. That means in frame 1 the station 1 can transmit data during its time slot, and in frame 2 it can transmit its data during its time slot. That means the transmission of the data transmission of station first is discontinuous. That means it is divided into the frames. Okay, that's why unlike FDMA system which accommodate analog transmission, digital data and digital modulation must be used with TDMA. Okay, I hope you all got the basic idea about TDMA. Let's see this diagram. In this diagram, the station 1, 2, 3 and 4 has each data in its time slot. Okay, that means the channel is divided into the number of time slot and each time slot is given for the each station. That means in first time slot the station 1 can transmit data, in second time slot the station 2 can transmit data, in third time slot the station third can transmit data, and in fourth time slot the station 4 can transmit its data. This is the process of TDMA. Let's see some features of TDMA. The TDMA shares single carrier frequency with multiple users. The non-continuous transmission makes handoff simpler. That means mobile assisted handoff possible. Slots can be assigned on demand, that is bandwidth supplied on demand. Less stringent power control due to reduced intruder interference. Power consumption is low. Transmission rates in TDMA are very high as compared to FDMA channels. And one more advantage of the TDMA is that in TDMA no guardband is used, hence no wastage of channel capacity is done in the TDMA. There are some disadvantages of the TDMA such that in TDMA, high data rates broadband system requires complex equalization. Due to burst mode, a large number of additional bits are required for synchronization and supervision. Call time is needed in each slot to accommodate time to inaccuracies due to clock instability. Electronics operating at high bit rates increases the energy consumption. Complex signal processing is required to synchronize within short slots. Okay, these are the disadvantages of the TDMA. Now let's see our third type, code division multiple access. The CDMA simply means communication with different codes. In CDMA, all the station can transmit data simultaneously. It allows each station to transmit data over the entire frequency all the time. Multiple simultaneous transmissions are separated by unique code sequence. Each user is assigned with unique code sequence. That means in this technique all the stations has its unique code sequence, and by using this unique code sequence, the stations can transmit its data. The CDMA differs from FDMA because only one channel occupies the entire bandwidth of the link. It differs from TDMA because all the stations can send data simultaneously. There is no time sharing. That means in CDMA, no time slot in the channel, hence it is different from the TDMA. Now let's see the concept of the CDMA. In this figure there are four stations marked as 1, 2, 3 and 4. 1, 2, 3 and 4. Data assigned with respective stations as D1, D2, D3, D4. That means station 1 has data D1, station 2 has data D2, station 3 has data D3 and station 4 has data D4. The code assigned with the respective stations as C1, C2, C3 and C4. Station 1 has the code C1, station 2 has the code C2, station 3 has the code C3 and station 4 has the code C4. Station 1 multiplies its data by its code to get D1 into C1. Station 2 multiplies its data by its code to get D2 into C2 and so on. That means station 3 multiplies its data with code and similarly station 4 does. The data that go on the channel are the sum of all these terms as shown in the box. That means the data goes through the channel is the sum of D1C1 plus D2C2 plus D3C3 plus D4C4. Okay. The various types of codes and coding methods used in CDMA systems are as follows. First one is autocorrelation codes. These are divided into two types, marker code and pseudonymous codes. The second one is orthogonal code, wash code, scrambling codes, channelization code and carrier modulation codes. Now let's see some features of the CDMA system. It reduces the multipath fading because the signal is spread over a large spectrum. Many users of CDMA shares same frequency. It has soft capacity limit. There is no absolute limit on the number of users in CDMA. It uses only one channel frequency during given interval. It has very high channel data rates. It gives signals of higher voices and data quality and small bit error rates. Its flexible transfer may be used. Mobile base stations can switch without changing the operator. Two base stations receive mobile signal and the mobile receivers signals from the two base stations. Let's see the disadvantages of the CDMA. The code length must be carefully selected. A large code length can induce a delay or may cause interference. The time synchronization is required. Gradual transfer increases the use of radio resources and may reduce the capacity. As the sum of power received and transmitted from the base station needs constant tight power control, this can result in several handovers. I hope you all now get the basic idea about TDMA, FDMA, and CDMA. Let's see the basic difference between them. The first parameter is idea. In TDMA, the segments sending time into disjoint time slots demand driven or fixed patterns. In FDMA, segments the frequency band into disjoint subbands, and in CDMA, spread the spectrum using orthogonal codes. Here, the segments means the bandwidth is divided into the time slot, here divided into the frequency, and the bandwidth is used for to send the orthogonal codes. Terminals in TDMA, all terminals are active for short periods of time on the same frequency. Terminals means stations here. Okay, that means all stations are active for short period of time on the same frequency. In FDMA, every terminal or every station has its own frequency. That means it is uninterrupted. In CDMA, all the terminals, that means all the stations, can be active at the same place at the same moment uninterrupted. The signal operation or separation. In TDMA, synchronization in time domain. In FDMA, filtering in frequency domain. And in CDMA, code pulse special receivers. Transmission scheme. In TDMA, it is discontinuous. In FDMA, it is continuous. And in CDMA, it is continuous. The next parameter is cell capacity. In TDMA, it is limited. In FDMA, it is limited. But in CDMA, no absolute time on the channel capacity, but it is interfaced limited system. The advantages of TDMA is that established fully digital and it is flexible. The advantage of FDMA is that it is simple, established and robust. The advantage of the CDMA is that it is flexible, less frequency planning needed and soft handover. The disadvantages of the TDMA is that guard space needed, that means guard space needed, multipath propagation, synchronization is difficult. In FDMA, the disadvantages are it is inflexible, frequencies are scarce resource. In CDMA, the disadvantages are the complex receivers, needs more complicated power control for senders. Okay. In TDMA, the standards fixed networks together with FDMA or SDMA used in many mobile networks. In FDMA, typically combined with TDMA and SDMA, and in CDMA, still faces some problems. Higher complexity, lower expectation will be integrated with TDMA or FDMA. I hope you all get the basic difference between FDMA, TDMA, and CDMA. Thank you.